We are live. Hi, good evening, everyone. Hi, good evening. Hi, Parishit. Good evening. Is my audio and video okay? Hi, Harsh. Is my audio and video okay? Awesome. Awesome. Okay. Today we have mostly a theory class, but this theory class is very, very important, especially in the interviews. Before that, remember to be consistent. It's not hard work, it's not talent that gives you success, it's always consistency in whatever field you are, right? Okay. I was going through the Node.js documentation, and in the About Us, we have this line, right? Uh, Node.js is an asynchronous, event-driven JavaScript runtime. What does this line mean? Let's discuss about this in today's lecture. What does asynchronous, event-driven JavaScript runtime means? What is asynchronous? Can any one of you know what is asynchronous means? Asynchronous basically means that if suppose you have a set timeout or you're making an API call, right? That is a time taking thing, right or wrong? That is a time taking thing. Suppose you have a timeout of 1 minute. Do you want your application to stop for 1 minute until unless that is completed? No, because that would create a blocking scenario, right? So, for example, if you are making an API call, by the time you can do other processes, right? In other programming languages, it is handled using multi-threading. But since JavaScript is single-threaded, it is handled a little different, right? That thing is called asynchronous. Asynchronous programming basically means that if there is some heavy task that needs to be done, it is not a blocking task. Other things can also perform in the same scenario, right? If we go downstairs, here, suppose you are making an API call, right? Once the API call is completed, you get something called a callback. We will discuss about callbacks also today. But after this is completed, this is called. And the rest of the things can also go on for the time being. If suppose this is a blocking architecture, then what would happen? It will wait for the API call to get completed, and sometimes API call does not get completed at all. So your user will be blocked throughout, right? If any API call is failing or it is taking hell lot of time. So JavaScript handles that very, very beautifully in a single thread. It uses something called event loop. It uses something called event loop. Screen is not clear. Is it clear now, Neetu? Can you see what is written in the screen or not? Or should I zoom a little bit more? I can see it over here. Okay, awesome. It uses something called event loop. This is uh, this is a very different approach from what other programming languages handle, right? They handle everything using threads. But in JavaScript, because it is single-threaded, it was made for very light applications or browsers like Chrome, Firefox, and other browsers like those, right? Browsers cannot occupy your whole RAM, your whole memory, or anything like that. It has to be very, very, very light. Okay. Because of that reason, JavaScript is single-threaded. But it uses something called event loop. What event loop is? How JavaScript works. Let's understand this. Tell me JavaScript, what are you? If I ask JavaScript what it is, it will say that it is a single-threaded, non-blocking, asynchronous, concurrent language. Right? Let's understand one by one what each of them means. Single-threaded means it is basically using only one thread. What one thread means? So whenever a process is happening, a single thread means it can do one thing at a time. That is what a single thread means. Okay. Non-blocking asynchronous. Non-blocking and asynchronous means it uh, does the heavy duty work afterwards, right? It does not block the heavy duty. It does not block any code because of some heavy duty work. Concurrent language, right? Concurrency means it can do multiple things at a time. That is, it can run the API call while executing the other steps. I have a call stack, an event loop, and a callback queue, and some other APIs and stuff. Right? JavaScript has something called a stack. It has a queue and it has an event loop. These are the three major components of JavaScript. Each and every line of code that you write in JavaScript is going through a stack, something called an event loop, and a queue, right? And some other APIs and stuff. For example, variables, constants, keywords, and whatnot. You know about them, right? These are the main three things: call stack, event loop, and a queue. So understand this: JavaScript uses both stack as well as queue, right? The stack is called a call stack, and a queue is called a callback queue. It runs on an engine called V8 engine that was developed by Google, right? If I ask V8, hey V8, do you have a call stack, event loop, callback queue, and other APIs and stuff? It would say no. It has a call stack and a heap. Just two things. V8 only has two things: a call stack and a heap. Okay. This is how a JavaScript would look. A V8 engine actually looks. It has a heap. Heap is basically the memory where your variables, values, and everything is getting stored. Right? Variable values, functions, and objects, all the memory allocations. Right? And it has a stack which executes your code. Right? If you're writing mat.sqrt, it goes to the stack to get executed. If you're writing bar function, it goes to the stack and gets executed. Foo, it goes to stack and get executed. Right? The call stack. There is only one thread. That is, there can only be one call stack and it can do one thing at a time. Okay? Let's understand the call stack. Suppose you have a function like this. You have a function multiply which multiplies two numbers and returns the value. You have a square which squares a value and returns the result. And you have a print square which basically calls the square and console logs its value. And you are calling print square with a value of 4. What would happen now? Right? We are learning how JavaScript actually executes the code. First of all, it will leave all this code, it will allocate some memory and leave this as it is. Now it goes to directly your function call, right? This is the code that needs to be executed. Rest of all does not needs to be executed until and unless they are called. So it goes directly to your print square, right? This function goes inside your stack to get executed. Stack is for execution. Memory allocation is for is in heap, right? Stack and heap. Stack is for execution. Memory is in heap, right? So if you want to execute this function, it will go into stack. It goes into stack, right? It has a link to this function. It will come over here. Now it will execute one line at a time. It will first see this var squared equal to square bracket n, right? Then it will go to this and it will go to this. All this goes under stack, right? Stack is LIFO or FIFO? Stack is LIFO or FIFO? Who can tell me? Will it execute multiply function first or will it execute the main function first? LIFO, right? So it will execute whatever has been entered in the last. So it will execute the multiply function first. It executes this. Whatever the return statement is, wherever it has been called, it will go over here. So this multiply a comma a would become 4 into 4, right? It will become 16. Then it has a return statement. It will go where it was called. So it will come over here, right? It will rewrite this again and say var squared is equal to 14, right? And then it will console log and gets out, right? And then executes the result and becomes empty, right? Stack has a property until and unless. Okay, we'll talk about that later. This you guys understood? How is it happening? It has only one thread. It can do one thing at a time, right? So it goes over here, print a square, it inserts it into the stack, right? It is calling this function in which a square function is getting called. So it will print, it will be inside a stack, right? And similarly, these two functions also comes inside the stack. Now it has a LIFO. It will execute one function at a time. So multiply goes away. Its result comes where it was called, right? Square goes away. Now console log is pushed to the stack. Console log goes away and your stack gets empty. Is the stack clear or not? Are there any doubts in the stack? I hope this was straightforward. Clear? Awesome. What would happen if you're calling a function infinite times? What would happen if you're calling a function infinite times, right? There is always a main function where everything starts, right? All the code that you are writing is inside a main function. JavaScript reads it inside a main function, right? So if you have a function which is calling itself infinite times, what will happen? The stack will be overflowed, right? The main function would come, then it would push your foo function inside it, which would push another foo function inside it, which would push another foo function inside it, which would push another foo function inside it, and things goes on, right? It will be overflowed, and you will get maximum call stack size exceeded. This error you you must have seen, right? In JavaScript, you must have seen this error many times. This comes when the stack is full and it cannot take any more functions, right? Now, let's understand blocking. What happens when the things are slow? For example, if you have this multiple API calls, it is making an API call to foo.com, it is making an API call to bar.com, it is making an API call to cox.com and things like those. Right? Now, since this is a function call, it would go into the stack. And if a function is there on a stack, it is there to be executed. Right? So it will try to execute this API call first. And you will see a loader. Again, when that execution is complete, it goes outside the stack. The stack can handle one thing at a time, right? Until and unless this foo.com API call is finished, it cannot do anything else, right? In a scenario when this is blocked, now it will make an API call to buyer.com. Again, a loader is shown, and once this is done, your console logs would happen. This loader can be there on the screen for infinite amount of time. It depends on the API call, whether it is passing, it is failing, whether you have handled the scenarios or not, and things like those. Right? Now let's understand what happens in the event loop scenario. There is a great video of what the heck is event loop anyways. Please Please search it on YouTube. You will find it very, very interesting. So what happens is, suppose you have a code like this. You have a set timeout. You are making a click event, right? Inside that you are setting a timeout, and you are putting console log, right? You are console logging hi. You are again having a set timeout, and you are console logging again. Now, how would JavaScript handle this code? See, first of all, this is a button on click, right? And this is a function. This has not been called. This function is getting called, so it will try to attach the event to the this thing, but it will move forward, right? It has a call stack. It has something called web APIs. This set timeout is not part of JavaScript. This is something called web API that each and every browser gives. Right? Each browser has a different set of functions which you can use. There are a common set of functions like set timeout, set intervals, which each and every browser provides. But this is not part of JavaScript. Understand this. Right? If I save and run, what happened? This goes to call stack. This goes to call stack. Right? Now, $on is a web API. Right? It is a time taking thing. It goes to the web API section. Okay. Again, console.log hi comes in the call stack. What will get executed? This console log hi or this on? You tell me. This console log hi will get executed or $.on? Hi will get executed. Why? Because this is inside call stack. Everything that comes into call stack will get executed immediately, right? If it is possible. So this hi gets executed, and you will see it goes outside the call stack. This hi is executed now. Right? Now this set timeout comes in. This set timeout is a time taking thing, or it can be executed uh, at the same time. It is a time taking thing, right? Even if the time interval is 0, because this is a web API, JavaScript will treat it as a web API. Right? Even if the time is 0 over here, JavaScript will treat it as a web API, and it will go to the web API section. It goes to the web API section, and a timer starts. right? Now again, this console log comes in, welcome to loop. Will this get executed, or is this a web API? This will get executed immediately. Right now, what results we have seen? We have seen hi, right? And then we see welcome to loop. Let me just open the inspect element. Okay, this web API comes in. Now console log hi. We see hi over here, right? Then this set timeout completes. This set timeout, and we see welcome to loop. Now there are two things in the web API section, right? There are two things in the web API section: $.on and set timeout. Whatever is finished first, whatever is finished first will move to queue. Okay, this is ready now. Okay, if I resume, this set timeout is coming over here. Let me pause it. Right, this set timeout comes to queue. This timeout that we have written outside. Okay, this timeout comes into queue. Now there can be multiple things over here. Queue is a FIFO or a LIFO. Queue is FIFO, right? So whatever comes first will be executed first. This circle that you see is the event loop, right? This circle that you see is an event loop. There is a simple if condition written over here. Whenever your stack is empty and there is something in the queue, move things into stack. But understand the condition. Whenever the stack is empty and there is something in the queue, then only move the first element to the stack. Get it executed, then do the same thing again. Right? There can be only one thing at a time getting executed in this stack. This set timeout, this set timeout is pushed to the stack and gets executed. Okay. Now if I click, then this API on click event moves to the queue. The stack is empty. What will event loop do? It will run and move this queue to stack so that it gets executed. Right? We have clicked the button. Now if I have multiple things, stack is empty. This timeout is running. Let me just click it over here. Right? It will move one thing at a time to the stack and get it executed. The timer runs, it moves to the stack, get it executed only if the stack is empty. Right? In this way, JavaScript handles your blocking scenarios. Okay? This is totally different from what other programming languages does. This is how Node.js has become so popular. Just because of this event loop, Node.js has become so popular that it can handle any number of traffic just because of this event loop. It will move it to the web API section, it will move it to the queue. Whenever the stack is empty, it will move to the stack to get it executed. Okay? Understood what asynchronous and event loop means? If somebody asks you event loop tomorrow, would you be able to tell them? Event loop has both a stack and a queue, right? Whatever is taking time, it will move to the web API section. When it is ready, it moves to the queue. There is a very small function written called event loop, which simply checks whether the stack is empty. If it is empty and there is something in the queue, move the first element to the stack and get it executed. There are many asynchronous languages, but they handle things differently. JavaScript is famous because of event loop, right? What asynchronous programming language mean? Asynchronous means that your code is not blocked because of set timeouts or any heavy duty work, right? The first word asynchronous we have learned, okay? Asynchronous basically means that your code is not blocked because of some heavy duty work. How JavaScript takes care of it? It treats each one of them as a web API, right? It has a stack, it has a queue, and it has a web API section. Whatever comes in stack gets executed immediately. Okay, and stack can handle one execution at a time. Now, if something comes in stack and it is a time-taking thing, it goes to the web API section. JavaScript will treat it as a web API. It goes to the web API section. When it is ready, it moves to the queue, right? And once the stack is empty, it has print all the non-blocking code. It will search for whatever is there in the queue. It will move this event loop will move this first element to the stack to get executed. Right? I hope there are no doubts. Varad, are there any doubts still left? Clear? Bikram, it is not just for fetch set timeout. For any web APIs, mostly whatever is time taking, it's treated as web API. Set timeout, set interval, API calls, any asynchronous things. Okay. Why 5,000 wala set timeout is executed first before 2,000 is because this is directly getting executed, but this is getting executed whenever you click the button. Okay, Haruna? If two things come at the same time, like promises and set timeout, which will be prioritized, uh, whatever finishes first. So if there are two things, promises and web API in the web API section, whatever is finished first moves to the queue, right? And queue has FIFO, so it will move back to the stack. If there is any API which is not responding in the web API, then it will never get into callback queue. Yes. Even if I know the response, can you explain with set timeout 0? See, even if you have set timeout 0, the set timeout is a web API, right? So what happens is, even if you have 0 over here, it will move to the web API section, it will go to the queue, and it will check when the stack is empty. So again, this hi and this welcome will get executed first before this click the button. Okay? It's never possible that two things are resolved at the same time. Can we have more than one timing taken API in the callback queue? Yes, you can have any number of things in the queue. queue also have some definite length, it depends on browser to browser, but mostly it can handle a very large number of queue. JS engine only executes one thing at a time because JS has the call stack, right? V8 basically JavaScript does the execution. Your V8 does the execution. And V8 only has two things. One is the call stack and the other is the memory allocation, right? So this call stack is mostly inside your V8 engine, not your JavaScript, right? V8 is responsible for compiling your code, not JavaScript itself. Okay, right. Let's get to the next topic. How do we handle the asynchronous in your code? For example, suppose you have to do some task A, then B, then C, then D. Okay, what is the JavaScript way of doing step-by-step execution? What is micro queue? Micro queue, I'm not sure. I heard that there are different type of queues like microtask queue and callback queue or other ones. Yes, there are. There are. This queue is also divided into multiple small things, but you do not have to worry about them. What is the meaning of runtime environment? Runtime environment means that everything is not done in the compile time. So, okay, there is how JavaScript is executed. So you write some JavaScript code, it is compiled. Compiled basically means that your memory allocation happens, right? Uh, any any errors in your code, right? That is, for example, if you have not put semicolon, for example, in some of the programming languages, it gives you an error in the compilation time, right? Whenever you write a code, it is first compiled, then it is ran, right? Then it run on your browser. All this, whatever we talked in the event loop section, it is happening in the runtime. Whenever your website is loading, right? For example, if you have an on-click event, it will only get executed when you click on a button, right? It will only get executed when you click on a button. So click on a button is something user is doing, right? So this cannot be happening during the compilation. It can only happen when your website is running, right? That is why it is called a runtime environment. Because all your code get executed when the user is using your website, when the website is running. That is why it is a runtime environment. Okay, Nitu? There are multiple type of queues. You do not have to worry about them. Okay, let's understand. Suppose you have a task A, then you have to do task B, then you have to do task C, then you have to do task D. What is the JavaScript way of doing it? The JavaScript way of doing it is, suppose for task A you have a function of with the name A, right? And in the parameters, you pass in the B function. Okay. Inside this, suppose you get a result out of it. When A executed, you have some result out of it, right? This result needs to be passed to B, okay? This result needs to be passed to B, which will get, say, R2, okay? And then your function C needs to be executed. First of all, A, okay? It will have some result. Inside this, you need to call B, okay? When A executes, when we have some result from A, then B needs to be executed, right? B also will have some result. Now C needs to be executed. C will have R3 and it will accept a callback called D, right? So A has a callback for B, B has a callback for C, C has a callback for D, okay? This is the JavaScript way of doing it. We say it is the callback way of doing it, okay? Suppose you have to perform B after A, then inside A, you pass in a function which performs the B task. Inside this B, you pass in a function which performs C task. Now your parameters or any variable for that matter can be of anything. It can be a number, it can be floats, it can be string, it can be anything, right? In JavaScript, JavaScript handles everything by its own. It can also be a function. This function, we take this and we say that it is a callback. Whenever something executes, whenever we have a function and we accept another function inside it, this function is called a callback function, right? Now, if I see this, B is passed as a callback function in A, C is passed as a callback function in B, D is passed in a callback function of C. Similarly, if you have n number of tasks, it will be very difficult to handle, right? The code will become very complicated. Are you guys understanding this? The code will become very, very complicated. Suppose you have do something, right? Inside that, we have a function with some result. Okay. In this, we have do something else, which will also have a result and a function with new result. Inside this, we have do third thing, right? It will accept new result and inside that, this will accept another function which will have some final result, right? And inside this, we have console.log, the final result, right? Then we have to handle all the failure scenarios as well. So the failure scenario for third will have a failure callback, right? Similarly, for second, we will have a failure callback. Similarly, for the first, we will have a failure callback. See how difficult this is to read, right? This is called a callback hell, right? Because it is a hell lot of effort to handle such kind of scenarios. Okay? In the latest version, or now the latest version is much more advanced, in the ES6 version, right? Which was released in 2015, I guess. I may be wrong, but uh, either it is called ES6 or ES2015. So I'm hoping it was released in 2015, right? Uh, so in the ES6 versions, there was something called promises which was introduced, right? Not just to handle callback hell. Many people have this thing in mind that it was only introduced to handle callback hell, but it is a totally different concept of in its own, right? Mostly people use it to handle callback hell, but it is a totally different concept of its own. Okay, so something called promises was introduced. In your previous example, if I have to do A, then B, then C, then D, right, and I have to handle all the error scenario with the same function, I can simply write A dot then and do B inside this, dot then do C inside this, dot then do D inside this, and at the last do dot catch and handle the error scenario. Okay, so promises has dot then and dot catch, just two things. These dot thens can be chained together. So whatever the result of B will automatically go to the function of C. Whatever is the result of C will automatically go inside D. Whatever, if there is an error in any one of those, it will directly go to catch. There is only one catch. There can be any number of dot then. Okay. Now promises, let's understand promises a little bit deeper. Promises, there is something called state machines inside engineering. Promises use this concept called state machines. What does state machine means? That you have certain states. In promises, there are three states: pending, right? Pending, fulfilled, and rejected. There are three states, just three states in promises, right? What is a state? A state is basically at what stage that promise is. For example, if you're making an API call, right? Now you are waiting for the API call. If you just made an API call, it goes first to the pending state, right? Or the waiting state. If there is a success, then it goes to fulfilled state. Or if there is an error, it goes to rejected state. Okay? So there are three states in promises. This is a state machine. State machine basically means that there are multiple states and it can go to one state to another. It cannot revert back. This reversion is not possible in state machines, right? It can go to one state to another, or it can, from pending, it can go to rejected. This is not there. It from pending, it can either go to fulfilled or it can go to rejected. But from fulfilled, it can never go to pending, or from rejected, it can never go to pending again. Right? How do we write a promise, by the way? There is a class called promise in JavaScript, capital P. So we create another object of it. It accepts a callback as usual, the JavaScript way of doing things, which has two things, resolve and reject. Okay? Suppose you are doing something, you are making an API call, whatever. You are making some asynchronous things. You are making, for example, you are doing set timeout, right? If the set timeout is done, you will call resolve inside this, that this is completed, okay? With say 300 millisecond timer. This is how a promise looks. Where did my mouse go? This is how a promise looks, right? You have a class called promise. You create a new object of it. It accepts a function, a callback function, which has two things, resolve and reject, right? They both are functions, JavaScript way of doing things. Whenever you want it to be to go to dot then, you call the resolve function. Whenever you want to go to dot catch, you call the reject function. Now, this promise, say I wrote it to my promise. I put it inside a variable called my promise. Now this has dot then and dot catch, right? This my promise has dot then. You can call a function. You can call if suppose in this. Acha, one more thing. Your callback. You have a function. Suppose this is a callback. Okay. The normal way of writing things is you have two parameters. You pass two parameters in this callback. You say success and you say failure. Okay. So the first parameter in a callback is for success. The second parameter is for failures, right? This is done so that if you just want to handle success, you can call this function. For example, if this function is named A, you can call this function with only the first parameter, result, right? If you want to handle error as well, you have the second parameter as error. In some of the libraries, you can see it switched. The failure comes first, then success. But this is the general norm. Always when you have a callback, you first pass in the success scenario and then the failure scenario, right? Now, if I have my promise, I can handle failure scenarios for each case also, right? So in each case, we will have a function A, for example, and the error scenario for A, right? This is a function, this is a function. Dot then B, error for B, right? If you want to simply finish this callback, right, then you can throw an error and it will go inside dot catch, right? So there are two ways of handling error scenarios in promises. One is you send it for each and every step. The other is you send it, you cancel the whole callback itself. You call the reject and it goes directly into dot catch, right? Suppose there are multiple things. right? If you have too many dot thens, if you have too many dot thens, right? With promise, you have dot then you have dot then you have dot then you have dot then. And when each and every step is done, you have the catch as well. When each and everything is done, you want to do something, right? You want a collaborated result of each one of them. Then it also has a function called finally, right? So you can use the finally method as well to do the last step. Okay. So this is called promise chaining, right? This is called promise chaining. I give you an example. Acha, there are multiple methods also to promises, right? We are JavaScript developers. We love functions that does things for us. We just need to call that function. For example, there are 50 API calls that you need to make, right? Would you like to wait for each one of them to get completed? Would you want to wait for each one of them to get completed? They are not very important. No, right? So there are multiple methods like promise dot all, right? Which is a function that accepts as an array all these 50 promises. So each one of them would be a promise, right? We have promise dot race. This also accepts just like this. We have promise dot all settled. It also has the same parameters, right? Learn about them. These are important, but this would be your THA. I'm not going too deep inside all these. Learn about them. So basically, dot all, what it does is when all of them gets executed, you get a callback with a consolidated result, right? You get an array with result one, result two, result three, and things like those. You can get it done after it, right? This makes all the promises uh, work parallelly. Okay, all the promises are called parallelly. So if you have 50 API calls, all of them gets called parallelly, right? All of them goes to the web API section together. They are all executed together in the web API section. All of them are done parallelly and then move to queue. When all of them have some result, you get it in the callback. If any one of them has an error, you get in the dot catch, right? Race tries to execute one thing at a time. All settled means everything is fine. Then only you get a dot then. Learn about them, right? Okay. So we learned we have a class called promise, which is basically dependent on state machines. It has two things, resolve and reject. Whenever you want the promise to go to dot then, you call it in the resolve. It also has success and failure, right? Or if you want to go to dot catch, you call the reject function. It directly goes to dot catch. Okay. It has three states, pending, fulfilled, and rejected. It can only move from pending to rejected or pending to fulfilled, not fulfilled to pending or fulfilled to rejected, and things like those. Right? Then we learned about dot then and dot catch. We learned about chaining and we learned about finally. Are there any doubts? Are there any doubts? In promises, in callbacks, in asynchronous programming, in event loop, everything is clear? No doubt? Awesome. You guys are great. I was hoping you get it out, but if you understood, that's great. Promises are not objects. Promises are objects in a sense, but promise is a promise, right? Promise is a promise. Everything in JavaScript is an object. 90% of things in JavaScript is an object underneath, but we do not say promise is an object. Promise is a promise. Wait, guys, I will go to async and await. Just have some patience. Now, we saw callback else dot then. Okay. So basically, whenever you call this resolve, it goes to dot then. That's it. If you call reject, it goes to dot catch. You can use this promise, for example, this is P1. Whenever you write this, you can use P1 dot then dot then dot then and things like those. And finally, you can use finally. Okay, Bikram? Now we have seen callback else. We have seen there is a way to write it in like promise. But have you noticed something? Have you noticed something? Both callbacks or promises are not blocking the execution. They both are not blocking the execution. Whenever this is done, whenever the callback, for example, if we have a function A and it is accepting a function B, whenever this is done, it goes to B, right? It is a way of blocking. It is a way of blocking. But whenever A is done, it goes to B. Similarly, whenever promise is done, it goes to dot then or dot catch, right? There is a different way. Again, see, if there are too many dot thens, if P1 has too many dot thens, this is a problem, right? So just a replacement of writing it like this, we have something called a sync and await. All the three things, callbacks, promises, async await, they are a synchronous way of programming. They stops the execution until and unless something is done, right? Just a different way of writing a promise is async and await. In this, we were used to write functions like this. Function with variable a equal to suppose something, where b equal to suppose something, and things like those. Right? We as a JavaScript developer were very used to writing functions like this. Now JavaScript asked us to change this into something like this. A dot then B dot then C dot then D dot catch E dot finally Z. Right? JavaScript asks us to write the function like this. We were not happy with it. We do not want whatever we have learned to change, right? So JavaScript said, okay, I hear you. Just do one thing. Write async before the function name, and whenever there is a promise, its result, its result, whatever is in the dot then, would be returned using a keyword called await, where b equal to await, b where c equal to await c, and similarly, right? Now it is very close to what we were, right? JavaScript said, is this okay? We said yes. We just have to use async and await. That's it. See, if we have finally na, we have the result of A into a variable A, we have the result of B into a variable B, we have a result of C into a variable D. Similarly, whatever you were doing in finally, you can have a Z, right? And a function which does all the calculations from the above. We have A, B, C. So for example, if you want to calculate the sum of A, B, and C, whatever was there in finally, you can put it inside variable Z. Okay. This function basically means to wait for A to get completed. That is A's resolve function to get called. Whatever would be the result of A would be A function would be placed inside variable A. Whatever would be the result of B function would be placed inside variable B. Whatever would be the result of C function would be placed inside variable C, right? And when wait for each one of them to get completed. Wait for A promise to get resolved. Wait for B promise to get resolved. Wait for C promise to get resolved. Again, remember, await only works with promises. This A function needs to be a promise. This B function needs to be a promise. Right? How do you write a promise? You write a promise using new promise. Okay? Wait for A to get completed. Whatever is the result on the success, put it inside a variable A. Whatever is the result when success, put it inside variable B, and things like those. When you get all the results, you can compute whatever you need to do in the finally in the same manner, right? Is this understood, async and await? Nitu, Sandeep, Nitu, is this understood? Awesome. Now, you should have asked me how would we handle dot catch? There is no way to handle dot catch in this scenario. Is there a way? This only gets called when we have the dot resolve, not dot reject. If this fails, this promises fails, this whole function will throw an error and your execution stops over here. If this function A fails, this whole function throws an error and your execution stops here. This only this only gets called with resolve, right? Not reject. Dot then and dot finally, we have handled it over here. But what about dot catch? So whenever you write an async function, you always wrap them inside dot try catch, right? In this way, if any of these promises fail, it will directly go to dot catch. Okay, so here you have to use try and catch always. Okay, is this understood? Async and await is just a beautification of writing dot then and dot catch. You can always use dot then and dot catch if the chaining is not too big. If the chaining is too big, it becomes again callback hell type of scenario where there are just too many dot thens. It's better to use async and await in that scenario so that your code looks beautiful. It's just a beautification, nothing else, right? But promises were not introduced just to handle callback hell. Understand this. Promises are a different concept altogether. Okay, awesome. Now we are done with asynchronous programming. There is a very small thing, event based. So your Node.js specifically, not JavaScript, Node.js. The concept that we have learned so far was of JavaScript and in turn of Node.js. This event-based thing is only for Node.js. Okay. So Node.js is an event-driven programming language. What does this mean? Node.js is an event-driven programming language or event-based programming language. What does that mean? It means Java Node.js will do anything on Node.js will do anything only when there is an event. Node.js will do anything only when there is an event. It won't do anything if there is no event. Okay? Event can be of any type. Event can be, for example, an API call, a get API call. If it accepts it, if it receives a get call, then only it will execute the function inside it. Otherwise, it won't do anything. Okay. So in this way, your computation is lowered down because if there is no event, then Node.js won't do anything, right? And it won't consume your too much memory, too much RAM, things like those. Okay? Node.js is an event-driven, event-based language. Whenever suppose you have 1 million traffic coming in, 1 million people are hitting the server within 1 second, right? It will again use event loop and it will have a stack, a web API, and a queue. Each and every traffic, each and every traffic will go to the queue and using the event loop, once it is finished taking care of one thing, it will take care of the rest of the person, right? But this process is so fast that it can handle 1 million even if they are in queue. Node.js is a scripting language. It is a language. pending what? Eventless thing. See, if suppose you created a server, okay, you created a server, uh, and you forgot to listen to a port. You failed to call the function, right? Then your whole code will not get executed. Or if you are listening to a port and no API calls you are hitting, then it won't do anything. Until and unless there is an event, there are multiple type of events written in Node.js. Until and unless there is an event, Node.js won't do anything, right? It has a library called event written inside it. Events. It has a library called events, which is very similar to socket, right? Just like sockets, until and unless you have an on or emit, you have an emit, your on would not work, right? So it is also based on dot on and dot emit. Until unless you emit something, dot on would not work. That is the simplest way of explaining things, right? In inside Node.js, there is a package called events, which emits, which is just like sockets, which emits things and is accepted by dot on function, right? If this emit, there is nothing to emit, this on would not work, correct? So simple as that. Node.js is a scripting language, yes. Node.js is a server-side scripting language. Server-side language as well as a scripting language. Do you want uh, an example of a scripting? Okay, let's come over here. If you uh, let me just go to slash and clear this out. Right. Runtime environment on the front end. JavaScript is a runtime environment. Node.js is a programming language. Node.js, okay, come over here. JavaScript runtime, not a programming language. My bad. Not a programming language. It is a JavaScript, asynchronous event-driven JavaScript runtime. I don't think so. There would be a language word used. Okay, my bad. My bad, Sandeep. It is a runtime. It is a runtime. Anyways, if you simply write node over here, you go to the node engine, right? Whatever code you write over here will get executed immediately. Let's say we have event emitter equal to require events. You can only use packages written, which is provided by Node.js itself over here, right? See, it says undefined. That means this line gets executed immediately. There was nothing to return, so it says undefined. Now, if I have an event emitter, if I simply print the event emitter, see, this is what I'm getting. It has some methods called once, on, emit, and things like this. Right? If I write a dot on function, say my event, right, and it has a callback which will receive a message. Okay, and I simply do console.log the message. Okay, see, it tried to execute it. Must be an instance of event emitter. Forget about this. It tried to execute it, but since there was no event, nothing happened. Now, if I emit something from here, it will call the function above and it will emit my event, right? Uh, my first event emitter. Let me just write it down again. I think I made some spelling mistakes. Constant event emitter equal to require events. Okay, I have to make a new object out of it. It is a class where event emitter equal to new event emitter. Now this would have the methods that I was looking for. Event emitter dot on my event. This will have a callback message, which I would console.log. The message the brackets are fine. Yes, the brackets are fine. Now I want to emit this event, right? I want to emit my event with a string of my first event. Okay, awesome. So this event came over here dot on, right? And it executed this function console.log, right? And it printed out the message that I've sent over here, right? And when this is all done, it tried to execute this function itself and it printed out true. This is how Node.js itself is written. Okay, there are multiple events, just like sockets. There are multiple events written inside Node.js, and there are multiple ons written inside Node.js. For example, when you make an API call, when there is an error, when there is a success, there are multiple things, right? But in a gist, this is how Node.js works. We have learned about event-driven, we have learned about asynchronous. This was today's class. Are there any doubts? Are there any doubts? All clear? Awesome. I hope then if you're coding, then you would remember all these things, how JavaScript executing your code internally, and you will not make any mistakes. Because this asynchronous thing confuses many developers. Why the console log is coming first? Why it is not uh, making the API calls? Why it is set timeout? Many people will say JavaScript is a funny language because it sometimes gives you the result which you are not expecting. This class is because JavaScript is a funny language. Right. Okay. So this was all for today's class. I will meet you in the Mahasabha VC. Be consistent, be crazy. Peace.